Hello, and today we're going through the binomial distribution, not including hypothesis testing. We'll do that in another video. So let's get started. So first, let's start with the conditions for the binomial distribution. The first condition is that there has to be a fixed number n of trials. So the second condition is that the trials need to be independent of each other. The third condition is, this can be in any order by the way, but the third condition is that there needs to be a constant probability of success. And the fourth condition is that there needs to be only two outcomes, either success or failure, and nothing in between. So now let's move on to the binomial distribution equation. So a binomial distribution, you write it out as x follows the binomial distribution of n and p. And the probability of x is equal to another small x is equal to n choose x times the probability to the power of x times 1 minus the probability to the power of n minus x. So where n and p, n is the number of trials and p is the probability of a success of each one of the trials. And to find the probability that, so you get exactly x amount of successes is equal to this formula here. So sometimes they say that n is called the index, p is the parameter, and when it says the squiggly line over here, it's basically saying follows the distribution. Now let's move on to a question for practice, where it asks, there are 2 red and 8 white balls in a basket. A person selects 5 balls each time placing the ball back into the basket. What is the probability of exactly getting 3 balls out of the 5 selections? So first we have 2 red balls, so we'll draw it out, and 8 white balls inside of a basket. A person selects 5 balls, so we can say that our n is equal to 5. And each time placing the ball back into the basket, so there's a fixed probability of getting either a red or white ball. So they're asking what is the probability of getting exactly 3 red balls out of the 5 selections. So we can make our success, first of all, let's make our success getting a red ball. So if we write a distribution, we're going to get x follows the binomial distribution of n. Remember, we have to leave it in terms of n and p. So n would be 5, and the probability would just be how many red balls over how many balls in total, assuming each ball has an equal probability of being chosen. So we'll do 2 over 2 plus 8, which is 10. Probability is 2 over 2 plus 8, which is equal to 2 over 10, which is equal to 1 over 5. So here we have our distribution x follows binomial np. And remember, we're trying to find probability of x, which is the number of red balls, is equal to 3. And remember, we can use the formula from before that we found here, and we can use the choose function. So it's equal to 5 choose 3 times 1 over 5 to the power of 3 times 1 minus 1 over 5 to the power of 5 minus 3. And this is equal to 0.512. And this is the probability of getting exactly 3 balls out of the 5 selections. If you don't know what the choose function is, I made a video on binomial expansions which explains it pretty clearly. So now let's move on to inequality cases. So when you have a binomial distribution and you're trying to find the probability. So instead of having a probability of x is equal to something, you're going to have a probability of x is greater than, like this, right? And this can be written as 1 minus probability of x is equal to less than r. And you use this equal to less than because values of r that are discrete values, because you could either get 1, 2, 3, 4. As we said before, we can only find a probability of 3 balls, not 3.5, because there's no such thing as getting 3.5 balls. So you can only get integer numbers, so you have to change it like that. And you can do this for multiple, like rearrange multiple probabilities, so you can get p of x is greater than equal to r is the same as 1 minus p of x is smaller than r. It's just to flip the sign. And because all probabilities add up to 1, so you can do this. And let's do it for the rest. So p of x is less than r. Can also be written as 1 minus p of x is greater than equal to r. And p of x is smaller than equal to r is equal to 1 minus the probability of x is greater than r. And what this means, so to show what it means, we could use an example of x follows the binomial distribution of 10 and say 0.6. P of x is greater than 7 would look something like this, where you have probability of x equals 8, not including x equals 7, because it's greater than, not greater than equal to. So it can't be equal to 7. And then we add the probability of x is equal to 9 plus probability of x is equal to 10. And we stop there because that's the maximum number of successes we can get, because there's n is the total number of trials is equal to 10. So let's try another example where you have, say we have a different distribution of x follows binomial of 20 and 0.7. And then the probability of 5 is smaller than x, which is smaller than equal to 10. What would we do? So we'll do probability of not 5, 6, x equals 6, plus probability of x equals 7, plus probability of x equals 8, plus probability of x equals 9, plus probability of x equals 10, because we do include the 10 here, and because we have the greater than equal sign or smaller than equal sign, we do include the probability of x equals 10. So now let's move on to a question where a boy has a 0.3 chance of scoring a 3-pointer in basketball. He takes a total of 23 pointers in every time he plays a game. If he does this for 5 games straight, he says that if he scores more than 27 points from 3-pointers alone, he has a good game. What's the probability that exactly 4 of these games are good? So we know that the probability of him scoring a 3-pointer is 0.3, and he takes a total of 20 3-pointers, so we can say n equals 20. And so a distribution of 3-pointers in a game is just x follows the binomial of 20, 0.3, where a 3-pointer is a success. So he says he does this for 5 games straight. He says that if he scored a more than 27 points from 3-pointers alone, he has had a good game. So 27 points, how many 3-pointers is that? So we'll have to do 27 divided by 3, which is equal to 9 3-pointers. And because he's scoring more than 27 points, it will have to be, so we will try to find what the probability of x is greater than 9 is equal to. And for this, we can write this out as 1 minus the probability of a cumulative binomial. So we get the sign looking like this in our calculation, where x is smaller than equal to 9. Because we know that this plus this is equal to 1. Because this goes from 0 to 9, the probabilities of 1 to 9, and this goes from the probabilities of 10 to 20, which should add up to 1 as a total. And this, we can just use a calculator. If you have a CG50, I'll show you how to do the calculation on the CG50s. So if you have a CG50 that looks something like this, to get the probability of a binomial distribution, you can go to statistics here on the menu. So first you will press menu button if you have anything else, and you'll go to statistics, and you would press exe, and then you'll go to distribution, so F5 in this case, and you go from binomial, and then you go to BCD to get more than one number. So if you have P of x is equal to, you go to BPD. But if you have P of x is equal to greater than or greater than, if you have inequality signs, use BCD. So in our case, we said was greater than 9. P of x is greater than 9. So we do not include 9. So our lower would be 10. And our upper would go all the way up to 20 because we had 20 trials. And our number of trials would be 20, and our probability would be 0.6. So I'm going to show you how to input these values if you don't, and make sure to have this as variable because it could be list, but we want it as a variable. So in this case, you would have our lower as 10, so we write in 10 like that, and then our upper as 20, write it like that, and then the number of trials was 20, write it like this, and 0.2, 0.3 was like this, and then you press exe to get your final value. You submitted everything in, and then press exe again, and now you have the probability that we need to find for our p of x is greater than 9. So now let's go back to the question. So on our calculator, it said we had 0.04796 as our probability. And I've just rounded this. So this is the probability of getting more than 9 3-pointers. So this is the probability that he gets a good game, or because he says he had a good game. And now the question isn't asking for the probability of getting a good game. He's asking what is the probability that exactly 4 of these games are good. So now we would have to do another distribution. So the second part of the question, we'll do another distribution of another variable. We can say y, which is the number of games that are good, and we said x was the number of 3-pointers per game, and y is now the probability of a good game. So y follows the binomial probability of the number of trials, which he says he does this for 5 games straight. So we'll substitute 5 as n, and the probability we're just going to use our value that we found before, 0.4796. And they're asking for the probability that exactly 4 of these games are good. So what we're going to do is probability of y is equal to 4. And this is equal to, so I'll show you in the calculator how to find this now. And back on the calculator, we go on statistics, we go on, if we go back, we're going to go distribution, binomial. And in this case, because we're getting an equal to sign, we're going to use the BPT. So we know that our x value that we're trying to find was, they asked what's the probability of getting exactly 4 good games. So we're going to do x is equal to 4, substitute that in. We know the number of trials is 20, which we already had written. But our probability, we're going to use our other probability that we had before, which was 0.04796. And if we put this in and press exe twice, we're going to get the probability of that he gets exactly 4 good games. So now let's go back to the question. So the probability of exactly 4 games, we looked in the calculator, was 0.012 rounded. And if you want to avoid any errors, I rounded it for a reason, because we left this rounded, we're going to have a lot of errors. So whatever value your calculator gives you, just make sure to plug in your whole value into the other one so you don't get any errors, unless you want to round it to avoid those errors if you're trying to get more decimal places. So this is the answer to our question, the 0.012 that he gets exactly 4 good games. So now let's move on to inverse binomial. So in this case, we're working backwards. So this is when you have, for example, p of x is equal to r, or you have an inequality here, and then they give you the probability of the outcome, for example 0.05, and you're trying to work backwards to find r. So in this case, you would use inverse binomial. So there's a few steps on how to do this. So the first step would be to leave the brackets inside. P of x is equal to r. So whatever inside your p of x, you make it like this if it's an inequality. If not, you can just leave it as equal to r. And they might give you the inequalities here on the outside as well. And then the second step is just to put it into your calculator, so into the inverse binomial in your calculator. So I can show you how to do it on the calculator later when we do a question on it now. So we're moving on, and they say we have a x follows the binomial of 20 number of trials and the probability is 0.45. They're saying probability of x is greater than or equal to r is greater than or equal to 0.9, and they're trying to find the value of r. So in this case, we would write it out. So we would have p of x is greater than or equal to r is greater than or equal to 0.9. And now you can write this out as 1 minus the probability of x is smaller than r is greater than or equal to 0.9. And you can also write this out as 1 minus the probability of x smaller than or equal to r minus 1. you can do this because if we draw a number line like this and say r is over here, because this part is less than r, so we would include every value from here, 1 less than r, all the way to the end, where this point is r minus 1. Because you don't include r because it's discrete values. So you can also write this expression out as the same as less than equal to r minus 1. So let's carry on the algebra. So write it like 0.9. And now you can rearrange the equation to get a negative probability of x is less than equal to r minus 1. Take away 1 on both sides, so you're going to get minus 0.1. And because you have a negative and a negative, you can just divide by negative 1 on both sides. So you get p of x is smaller than or equal to r minus 1. And because you multiply by minus 1 on both sides, you're going to have to flip the sign in the inequality. So you're going to go like this, and you're going to be left with this. And now, all you have to do is put your values into the calculator. So I'll show you how to do that now. So to use inverse binomial, you'll start up your calculator. And you would go, again, menu, and then go to statistics over here, and then you would press distribution, binomial, and then now you would go to InvB, which is inverse binomial. Your error would be the probability that your p of x is equal to. So in our case, it was 0.1, so our probability was 0.1, and our number of trials was 20, and our probability was 0.45. So now if you press exe and press exe again, now it's going to give us a warning, and we'll cover this later, but it's going to give us a value. So if you press exit, you'll get a value. So your inverse binomial will give you a 6. So now let's go back to the question. So by using an inverse binomial, we've got that r minus 1, because we've taken it out. The inverse binomial just gets rid of the p of x, so you just leave the r minus 1. And we know that this is equal to 6. However, remember that warning we've got in the calculator from before. That means we don't know if this is accurate. So we're going to have to test this by putting it back into the calculator to test whether this is smaller than, so the r minus 1 is smaller than 0.6. So in our case, if we substitute r minus 1 back in, so testing, because we know our r minus 1 is equal to 6. So let's substitute that back into this equation up here. We know that p of x is smaller than or equal to 6. And now what we will do is using the binomial here, and this, we're going to find out what value we get. And if it's smaller than or equal to 0.1, we accept that this value. And then we're going to test values nearby it. So here we would go back to start, and we go again, menu, statistics, distribution, binomial, and now we go to BCD. And because we said it was smaller than or equal to 6, we would do our maximum would be 6, so our upper would be 6, and our minimum would be 0, all the way down to 0. And because we have a number of trials of 20 and the probability is 0.45 again, so we press exe twice and we get 0.12993 as our probability for x is smaller than or equal to 6. And this is greater than 0.1, so it can't be smaller than 0.1 as they stated in the question. So let's go back to the question again. So we got our value as 0.1299 and etc. Here we don't have to really round it too much. If we substitute this value here into our original one, we would write 0.1299 recurring is smaller than or equal to 0.1, which is not true. So this is not true, this is impossible. So now what we will do, so that means our r minus 1 cannot be equal to 6. So because this is slightly large, we're going to test the probability that is a bit smaller. So we're going to test the probability that's next to it. So we're going to test p of x is smaller than or equal to 5, and p of x is smaller than or equal to 7. And whichever one of these is smaller than or equal to 0.1, we will use our value of r minus 1 as either 5 or 7. So let's check. And if we don't get any of these, we're going to have to carry on going on values next to it. So if we put this into our calculator, we're going to get the same process as before, but instead now you substitute your lower as 0 and your higher as 5, and we get 0.05533, which is less than 0.1. And now let's check. So less than equal to 7, so from 0 to 7, and we get a value of 0.252, which is not less than equal to 0.7. So we know now that if we substitute our value of r minus 1 as 5, we're going to get something that's less than equal to 0.1. So r minus 1 is actually equal to 5. And now we rearrange, and to make our r the subject, we're going to get r is equal to 6. So this is the answer to this question. So now let's move on to the expectation. So for the expectation of the binomial distribution, if you have a distribution that looks similar to the ones we've done before, so x follows the binomial of n and p, the expectation, the formula for the expectation, e of x, is equal to n times p. And the expectation is the most likely outcome. So just to make sure, test your values around n and p. So if you get p of x is equal to np, and then you get p of x is equal to np plus minus 1, and if this one is more likely, your value here is your most likely outcome. So now this is the expectation. This formula takes you close, and if you're like a 0.5 or if you have a decimal np, you're going to have to round to find the new np and test higher and lower to find whichever one is more likely, so you get the most likely outcome. So now let's move on to a question where they're asking x follows the binomial of 120 and 0.2. What's the most likely outcome? So in this case, we're going to just find the expectation first. E of x is equal to 120 multiplied by 0.27, which is just np, which is equal to 32.4. And here we're getting a decimal outcome. So what we're going to do is test whether p of x is equal to 32 is greater, or p of x is equal to 33 is greater. So putting into our calculator the BPD, p of x equals 32 is 0.081841, and our p of x equals 33 is equal to 0.0871989. And because this is the larger value, now we're going to test one more time, one a bit larger, so 34, and see what we get. P of x equals 34, and we get 0.0763945. And this one is smaller, so because this is the most probable outcome, our expectation, so our most likely outcome, is equal to 33 because we substituted 33 as x. And this is the answer to the most likely outcome of this distribution. So now let's move on to another question. They're saying the expectation is 100 and the probability is 0.3. So they're saying your e of x is equal to 100, and the probability from x follows a binomial np. Your p is equal to 0.35. Find a number of trials done. So they're saying find n. And because we know the formula of e of x is equal to np, because we know what p is and what e of x is, we can rearrange to get e of x divided by p is equal to n. So we'll do 100 divided by probability 0.35, and we get 285.7. Now you can't have a fractional number of trials, so what you're going to do, what we can try to do, is do x follows the binomial of 2, 8, round it up, 6, comma, probability of 0.35. And then we're going to try a probability of x is equal to 100 and test the values of 101 and 99 and see if 100 is the largest one. So we're going to get probability of 100 using this distribution. We're going to get 0.4941664. And if we test probability of x is equal to 101, we're going to get 0.490026, which is less than 100. And probability of x is equal to 99. And we're going to test this, and we're going to get 0.4907688. And we realize that this is our largest value. So the expectation following this distribution is equal to 100. So now we've proved that the rounded version of this has a most likely outcome of 100. So the value of n would be 286. And this would be your correct answer. That's the end of the video. Thanks for watching. I hope this was useful for you.